All right, so what we got is we're going to do transformations today, okay? And you've done most of these before, but what's going to be a little bit different is all of those functions that we did way at the beginning of the chapter, where we did like the basic ones like linear, quadratic, cubic, absolute value, all of those. Then we've added like the square root function and some different ones, the cube root function, some different ones that we don't see quite as much. All of those are the functions that we're going to be dealing with today. And we're going to do transformations to them. And the one thing that's not going to really change is the rule that happens to it, okay? The function's going to be different, and the rule is going to stay the same no matter what function that we have, okay? And I'll show some examples as we go throughout the lesson today. But there's going to be a lot of different transformations that are going to happen here. And so we'll just kind of take it one at a time and kind of talk about some of the different ones. The first one we're going to look at are vertical and horizontal translations. Okay, a translation, another word that might sound a little bit more familiar to you is like a slide. We're going to slide the graph up, down, left, or right. So when we say vertical and horizontal, vertical would be sliding it up and down, horizontal would be sliding it left to right. So we're just going to take whatever graph we have and we're going to move it some direction, left, right, up, or down. And there's really two different kinds of movement here, depending on the sign that I have. You can have vertical movement or you can have horizontal movement.
Hi, Mom. Please stand for the pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. The student section theme tonight is USA. If you'd like to purchase a theme night kit from Stuco, please stop by our table at lunch. Students attending the football game tonight will need to have their passes set up on GoFan to enter. If you don't have your GoFan pass set up, you'll need to pay the $7 admission fee. If you have questions or need assistance setting up your pass, please see Lindsay in our activity office. For the pep assembly, please stay with your grade level in the designated section of the stand. Good luck to the football team tonight as they take on Augusta. It is also Bueller Brave tonight. We will recognize all current and former military members and first responders for their dedication and sacrifice. NB Church, 2 blocks south of Bueller High School, will be hosting a fifth quarter tonight after our game versus Augusta. Bring a friend and enjoy games, friends, and good food. Any good luck tomorrow to our cross country team as they run in Wamego, as well as the freshman volleyball team who plays in Hutch, and varsity soccer playing in Goddard. Have a great day, full crew.
Okay, so vertical movement. Now, I'm just doing a real basic general rule here, okay? F of x is the function that we're starting with. It could be quadratic, it could be cubic, it could be any of those functions, and we'll keep talking about that today. There's probably a group of about 7 or 8 functions that we could apply any of these rules to, and all of these rules will stay the same no matter what the function is. But if I do a plus b after the function, okay, whatever, and b is just some number, it could be 3, it could be 4, it could be whatever, okay, then that's going to make the graph shift up. And if I put a minus b at the end, whatever number that is, then that's going to make the graph shift down, okay? So examples, and then let's go ahead and talk about horizontal, and then I'll show you a couple of examples of these. Okay, when I put the number on the inside, in this case, my number will be D. Okay, I'm just using a variable, I'm not using a number. We'll use some numbers here in just a second. But this is saying it works for any value. And here's the one that's probably a little bit tricky. If I did x minus d, when we see minus, we typically think we're going to move it, because it's horizontally, we think we're going to move it left. But it's actually opposite of what we think. So this is going to go right d units.
Is that a multiplication sign?
Minus sign, sorry. Yep. And then left d units. So it's going to be opposite of what we think. When it's on the inside, we think opposite. So I'm going to give you a couple of examples here. F of x equals x squared minus 6, okay? We know that this is a quadratic function. X squared would be the basic function, right? And so to that original function, we are putting a minus 6 at the end. And because the minus 6 is after the function, it's going to move it down 6 units, okay? And you could put these into your calculator and kind of verify what's going on. But that's going to be the question that we're going to have to answer today, is what is happening to the graph? What kind of change or transformation are we applying to the graph? This time, the number is inside of the function, okay? We have an absolute value sign, but we have x minus 4. So when it's inside of the function, it's going to be one of these two, because it's inside. Here I know it's parentheses, but here, because our function is absolute value, we're going to put it inside the absolute value. And because it's inside, if it was minus, we're going to move it right, okay? So here we would say that this graph is going to move right 4 units. So it's going to take that v, okay, and I'll show you a couple of graphs here in just a second, so I can pull up these all at the same time and just kind of show you the application that's taken place. And then the third one here, this is kind of a combo, right? Because it has a number on the inside of the function. Here my function happens to be the square root. So we've seen 3 functions already. We've seen x squared, we've seen absolute value, we've seen square root. The functions are going to be different for each problem that we see. But the rules will stay the same no matter what function we have. So here, because the number's on the inside of the square root, when it's on the inside, it's going to go opposite. So this is a positive 2. So we're going to say that it's going to go left 2, and then the minus 3 at the end tells me it'll go down 3. Okay. Just to show you a couple of these on your calculator, and that I always like to remember, when it's vertical, we're always going to move it in the same direction as what we think, and when it's horizontal, I always like to remember that it's going to be opposite of the sign. Because a lot of times when we think minus, we think left when we think horizontal, but it's actually going to move the opposite direction. Okay, so just remember, when it's on the outside, we're going to move it up or down in the same direction. When it's on the inside, we're going to move it the opposite direction. Okay, I think that's the easiest transformation. I start with that one because I think it's the easiest of the ones that we're going to do today. The second one we're going to look at is reflections. One of these we're pretty familiar with. The other one is probably not quite as familiar to us. And so we're going to do 2 different reflections. I could reflect a graph across the x-axis, and then I could reflect a graph across the y-axis. Okay, either one of those might be a reflection that we might do. The first one is the one we've seen before. reflection across the x-axis. If I said, once again, that f of x is my original function, then y equals negative f of x is going to reflect that graph. Okay? So you're going to put a negative out in front. The easiest example that you might remember would be like y equals x squared. Okay, if y equals x squared is my original function, it's a parabola, right? If I put a negative in front of that parabola, what's it do? It flips it upside down, right? So it's reflecting it over the x-axis. It just, we say, sometimes we use that word flips upside down, but if you really want to get mathematical terms with it, it's reflecting over the x-axis. All the points are reflecting into the axis below it, over the x-axis. Okay, for the y-axis, if I said f of x is my original, in order to flip over the y-axis, we're going to have to put a negative on the inside of the function, whatever that function is. Instead of out in front, we put it on the inside. Okay, one thing to kind of remember here, when we talked about symmetry way back, a couple days ago, when we did y-axis for symmetry, we always said it was the opposite of x. Okay, so that's one thing you can kind of remember here, where it kind of ties into what we were doing when we did symmetry. So I'm going to show you a couple of examples here. If I gave you, let's do y equals negative x squared plus 4. Okay? I'm going to bring in some of our movement that we did just a second ago. What's the plus 4 going to do here? It's going to move it up 4. What's the negative in front of the x squared going to do? It's going to flip it upside down. Okay? So there's two things happening here. It's going to go up 4, and it's going to flip the x-axis. If I show you what's, okay, the one that I think is, going back to our rules that we talked about here just a second, and there's two of these, okay, and we're going to kind of break these up. The words that they're going to use are a vertical, stretch, or shrink. So if I had a parabola and I vertically stretch it, that means I'm stretching it up and down, right? So it's going to make that parabola get really skinny as I do that, okay? If I shrink it, if I take that parabola and vertically shrink it, that means I'm kind of like compressing it. I'm pushing it down, and what that's going to do is that's going to make that parabola get really wide, okay? And so think about the direction that you're moving. Vertically is up and down. Shrink means we're compressing it, making it smaller, okay? We're pushing it down, which kind of think about like if I had a ball of Play-Doh or something, right? If I compress it, if I push down on it, it's going to get fatter, right? It's going to widen out. If I shrink it or stretch it, then it's going to turn into like big, long, skinny piece of Play-Doh or something, okay? So think about it vertically, though, when we do this. So in this case here, f of x still going to be our original, whatever that function is. We have to have some function that we're applying the changes to, okay? If it's a vertical stretch or shrink, then the equation is going to put some number out in front. The number might be 2, 3, 4, okay? We're not going to do negatives here because negatives makes a flip, right? So we're just talking about a positive number, not worried about negatives here. If that a value is bigger than 1, and I put that in absolute value here because, like I said, we don't want it to be negative. Negative is going to have a different application to it. So all we're doing is looking at the number itself, not looking at the sign. So we're going to say take the absolute value of it. Only pay attention to the number itself. Then it will be a stretch, a vertical stretch. It's going to stretch it. So the bigger the number, the more it's going to stretch. Okay? And then the other one is going to be a shrink. So we're looking at numbers between 0 and 1. So a number between 0 and 1 would be a number like what? A half, right? So we're looking at fractions. So a half, a fourth, a third. Once again, the smaller the number, the more it's going to compress or shrink. Okay? And I try to use different words. You know, sometimes you might have heard like wider or fatter or something like that. Those aren't necessarily mathematical words, but it kind of makes more sense in our mind of what's going on. When you look at the textbook and when you see the wording that they use, they're going to use shrink and stretch. And so those are the words that we're using here. But you could describe it a little bit different way. Okay? And I don't have a problem with you doing that, but you do need to understand what stretch and shrink are talking about as well. Okay, on this, I'm going to do this on the same page because I'm going to talk about the relationship between these. We can also do this horizontally. So we could have a horizontal stretch or shrink. So a horizontal stretch or shrink. When I talk about compressing it vertically, if I compress it vertically, that's going to make it get wider, right? That's going to have the same impact as stretching it horizontally. So compressing down is going to have the same impact as stretching it horizontally, okay? Vice versa, if I stretch vertically, is going to have the same impact as pushing it in, left and right, okay? So those two are going to have the same impact with one another. So that's why these are going to have a little bit of relationship, but the number's going to be in a little bit different spot, okay? So based on where the number is at is going to change what we've got here. So first of all, when we do this one, when we do a horizontal stretch or shrink, the number is going to be on the inside of the function. So if my number is bigger than 1 on the inside, then it's going to be a horizontal shrink, okay? We're going to shrink it. A horizontal shrink would be the same as a vertical stretch. Those two go together. Because if I stretch it vertically, okay, then that's the same as the other. And then if I go here, a horizontal stretch, I'm going to stretch it going this direction, would be the same as a vertical shrink or compression or pushing it down, okay? So what we're going to say here is that these two go together. But the numbers are going to look a little bit different, right? The numbers that we put in there are going to look slightly different based on where they're at. If it's out in front, then we use the word vertical. If the number's on the inside of the function, then we use horizontal. So then we have to think about the wording that goes along with that, okay? I'm going to show you a couple of examples here so you can kind of see what's going on and maybe understand a little bit better. Go. When it's on the inside, it's going to be a shrink, so this would be a horizontal shrink. I'm going to give you absolute value, okay? Y equals absolute value of x is my function, okay? You could do this with any other functions. If I put the 4 out in front, then we have to identify what type of change is taking place. And sometimes it helps to graph it, right? I'm going to go ahead and graph this and just kind of show you what it looks like. But because the number is out in front, are we doing vertical or horizontal here? Vertical, right? Because the number's in front of the function. But if I were to graph this, is that this one stretch vertically by a factor of 4. If I put the 4 on the inside, okay, these two are two completely different equations, but they're the same graph, right? And that's why by graphing it, we can kind of see that those changes taking place. So here I would say shrink horizontally by a factor of 4, or horizontal shrink by 4, however you want to say it. Okay. So 2 different words that describe it based on where the number is at, but it's still the same graph. Okay, so there's still a change being applied to it. Okay, there's one other thing I want to kind of go through with you, and I think it's easier to show you a couple of these from your book. If you want to open your books, you can. If not, I can just put it up here as well. There is a couple of problems today where they're going to give us an ordered pair. So instead of giving us a function like y equals x squared or y equals absolute value of x, okay, they're just giving us a point that's on f of x. Okay, and if you have your books, this is on page 161. If not, that's okay too. And I'm looking at number 37. G of x equals 1/2 times f of x. Okay? They're asking me what's happening to this, but not only what's happening, what would be the new ordered pair on this new function? Okay? So a couple of different ways that you could think about this. The number's out in front, right? We have a 1/2 in front, so it's going to be a vertical stretch by 1/2. Or a vertical shrink, I should say. Okay? But here's the easiest way. What does f of x really represent? Yeah. And it's a y value, right? F of x and y are always the same thing. So it's really like me taking 1/2 times y. 1/2 times the f of x value, which is really y. So half of y, my y value is 4, so I just take half of 4. Okay, so my new point here would become negative 12.2. Nothing happens to the x value. We're only applying the change to the y value. Okay, let's look at 38. G of x equals f of x minus 2. Okay, and once again, we're trying to decide what's happening here. We're applying the change to the x value, but when the minus 2 is on the inside, what does that tell me? What's happening? What's changing? What direction is it going? Okay, and here's the one we got to be really careful of, right? Yeah, because minus sign we do think left, right? But this is one when it's on the inside, it's always going to be the opposite. If it was on the outside, we're gonna go up or down, but when it's on the inside, we're gonna go left or right opposite. So here, we're actually gonna go right 2. And if I moved this point right 2, what value is gonna be changing? The x, okay? So we're gonna take negative 12 and we're gonna move it 2 to the right. And so that would put me at negative 10, 4, okay? So when you apply these changes, you're only applying it to one number, okay? Unless there's 2 changes going on. But I think most of the ones in that little group only have 1 change happening to it, okay? Let's do one more. Let's do 44. Just trying to give you some different looks here. When I put a negative in front of the function, the original function, what's it going to do to the graph? Flip it, right? It's going to flip it over the x-axis. So what value is going to change? It's going to be the y. Yeah. And here's the other thing we talked about, right? We're doing the opposite of f of x, but f of x is really what? F of x and y are the same thing. So really this is another way of saying the opposite of y, okay? Just so you can kind of read it that way. And I think that can be helpful. Just remember that f of x and y are the same thing. So when the number or the sign or whatever is out in front, we're applying it to f of x or the y value. When the number or whatever is on the inside, we're applying it to the x value, okay? So kind of keep that in mind as you're doing these. So in this case, our y value is what's changing. So only the 4 is going to change and it flips upside down. The x value is still going to be at negative 12. So now my point would be at negative 12, negative 4. Okay. So it's a little bit different way of looking at it because you're not applying it to like an equation or a function. You're just applying it to a point. You're still applying changes to it, the changes we've talked about, but you're applying it to just an ordered pair. Okay? Questions on any of those? So just a little bit different way of thinking. So I wanted to show you those because you're going to have a couple of those on your assignment today. All right. So your assignment is also on 161 today. As I told you guys at the beginning of the semester, I don't try to overload you with a bunch of homework, right? Hopefully you don't feel like you've been overloaded with a bunch of homework, but I try to go through and pick out problems like these are the things that we need to know. And so if you're doing those assignments, those are the problems that you're going to see on quizzes and tests and things like that. So it's absolutely critical that we're doing our assignments and don't just go and look at my key and say, oh, yep, I see what Mr. Root is doing here. Make sure you're doing it first, trying it first, and then using the key to check so that you're getting that practice. And that's really, really important, okay?